Hello everybody, and welcome to another video with me, Ro from Scalpel and Stem. So today we're going to be using one of the coolest pieces of equipment that I have in the lab. It is a biocoupler by Plant Cell Technology. I received it when I became an ambassador for them. That was about a year ago. We moved the lab this year. Things have been generally chaotic since then. We're now getting back in order. Things are moving in a positive direction. It has been quite a while since I've done anything regarding Plant Cell Technology and their products, which are awesome, and I use them all the time. At some point I'll be doing another video on plant preservative media and my uses for that. This is not that video. This is the Plant Cell Technology biocoupler video. So this is a standard, these are jars, 300 mils quart jars. I'm not 100% sure, but what's cool is this little dude connects the two. Then I will show you the biocoupler up in person, the actual ring that does all the work. So this is the piece that does all the work. It is a little tray on which your plants sit. We will be rotating a liquid media. It'll be on one side, we'll rotate it, the plants will get submerged in liquid media, and then we'll go back and forth. The advantages to this should be quicker growth because they get 3D all the way around nutrients, and so I really like to see how this works out. There's a lovely vent to allow for air exchange and stuff like that. Very nice quality piece of equipment. So just an FYI, if you're using a pressure cooker, the two things that have happened to me so far. Number one, when I went to pressure cooker, I had the water level too high and the vent allowed water to get into the media and then it was diluted and we ended up having to pitch that batch. I solved that problem when I put it in the pressure cooker by putting aluminum foil around the top of this and making sure around this particular couple piece, not around the top of the jars, but around this. And I'll show you when I put it in the pressure cooker. But I put aluminum foil around this coupler right here and that worked. The second problem we have is contamination. It was not the biocoupler's fault because both of the plants that I put in vitro to do side by side ended up getting contaminated. So when I do finally put plants in vitro and put one in a biocoupler, I am going to take one jar, split it into two, and do a side-by-side comparison so that we can see really in time which grows faster. I did that. I had chosen philodendron giganteum blizzard, some really pretty ones, and both the ones that went on my regular agar-based philodendron media and the ones in the biocoupler got contaminated. And that means it's on me. Something happened during the subculture process. They were clean going into subculture. They were not clean coming out. I have added a stir bar on my magnetic stir plates to my jar. I'm going to add 200 mils of water, 200 milliliters of water here. And I'm going to go ahead and start stirring. Alrighty, 200 milliliters of water, 6 grams of sugar. So because it helps me keep track, even though I don't have a bunch of biocouplers going on, in case for some reason I have a brain fart and I don't remember what kind of media this is, rather than put a label, which will probably come off in the pressure cooker, I will put 1 drop of blue dye. This is just regular food coloring. Up next, I add plant preservative mixture from Plant Cell Technology. I will do a video on this, as mentioned, plant preservative mixture, on what its uses are and how to use it. Up next is 0.9 grams of my MS media. Making a little bit of a mess, but there we go. We're going to add the same concentration of multiplication hormone to my aqueous mixture that I do to my solid or agar-based. So for 200 milliliters, it comes out to 0.2 milliliters of BA, benzylamino-purine solution. We're using a 1 milligram per milliliter solution, and that's why it comes out to 0.2 milliliters of the solution for 200 milliliters of our media. Here is my pH meter with its electrode. The pH meter I purchased has both a pH electrode, an electrode that just measures the pH, as well as a temperature probe to make sure that the temperature dependent pH is correct. If you want to see more on that, let me know. Comment in the video below and we'll talk about the temperature dependence of pH. But for now, I stuck with this meter because I find those stick meters to be inaccurate and I go through those pretty quickly. So currently we are reading 4.29. Our goal is to get to 5.8. It's going to be a little bit challenging with our tools because we're used to working on the 1 liter basis. So it's going to jump pretty crazy each time I add 1 drop. So I'm going to go real gently and wait. As you can see, it might go all the way up to 5.8 with just that 1 drop. My tolerance, the window in which I will accept the pH, is anywhere between 5.7 and 5.9 on this scale. I just don't have the tools to get any closer to that. And look at that, it's taunting me. Like I literally need like very, very little. 0.69. You know, at this point, if I add any, using the tools that we have without having like a pipetter, I would blow right past 5.8. I'm going to leave it at this. It did seem to settle at 5.7, so we're going to go with that. I would rather be as close as I can be, given the tools that I have, than be completely off. And if I blow past it, then I have to get pH down involved, and then it's just back and forth, and that would be silliness. So yep, we're going with 5.7, and even though the hourglass is off, it still is going up. So I don't know why it's giving me a little grief. But we're going with 5.71. There you go. After measuring the pH, I'm going to prepare this jar and put it in the pressure cooker next. Here's my biocoupler with my prepared media and the aluminum foil around it to protect the vent while sterilizing in the pressure cooker. So at this point, I was going to show you the subculture of the philodendron I had chosen into the biocoupler. But I realized when I was doing the biocoupler formulation, I did not adjust the ppm to the correct amount. So the correct amount for 200 mils is 0.2 milliliters of ppm. That's what I use in my philodendron media. So at this point, I'll let you guys take a look at this video and I will make yet another batch. Trial and error. When you're trying something new, don't be afraid to fail, but learn from your failures.